We left off last time saying this way of calculating things really wasn't the best. Hopefully about now you get the feeling like, we had one statement in our Excel and one statement in our Visual Logic, and now you're saying that's not enough? What in the world's going on? Well, this is the progression. The Visual Logic allows you to get an overall high-level look at the algorithm, but when you implement it in programming, there are certain things you're going to have to do. Enough gobbledygook. First of all, let's just say this statement is not going to be needed at all. So we'll just delete it out. Second, what I need to do is to take my text input, the 5 for base, the 10 for height, and convert it into a real number. You go, well, isn't 5 a number? Well, no, it's not. When 5 is on the screen, it's a character item. Numbers are internal. When you do the binary module in this course, you might get some understanding of what's going on behind the scenes. But know that for now, the 5 you see on the screen is not really a number, and the Visual Basic compiler is doing some stuff behind the scenes. Programmers don't like that. Programmers want to control what goes on, and we're going to get our first steps at that. The first thing we need to do, though, before we can convert that character 5 to the real number 5, is to set up a memory variable for it. And that's done with the DIM statement. Now, dim could stand for define in memory, or maybe it stands for dimension, meaning giving a size, or all of the above. But we have some different choices. We could have a integer, which means we could only enter whole numbers. Did we think back in our test plan that integer was possible? No. We wanted to be able to enter decimal places. So that means we need to choose one of the other items, such as single or double, which allow decimal places. We're going to use single. Now, in order to clue in the reader of the program that we've decided to use a single one, we're going to prefix the name of the variable with SNG, short for single. And sure enough, we're going to dim it as single. As you enter this, you will see a squiggly line under the variable name. That happens until it's actually put into use, then it goes away. Notice that I used camel casing when I defined the number. SNG is lowercase, then an uppercase letter, followed by the rest of the word in lowercase. Be sure to follow this standard when you name variables. Finally, we need some place for the answer. And we have our 3 variables defined. So that's step number 1, is defining the variables. Step number 2 is converting the 2 inputs. Now the nice thing here is you can from here on out type everything in lowercase and it fixes it. So I can go SNG base equals convert dot to single me dot txt base dot text. Notice how we constructed all of that using the tab key. I'll do the same thing with single height. I'm not typing any uppercases. Convert to single me. You do need to learn how to type the parentheses. Me dot txt height dot text. Notice now that our 2 dims up above, the squiggly lines, have gone away from underneath single base and single height. Now we can do the math. SNG area equals SNG base times SNG height. Notice I didn't capitalize anything, but when I hit enter it will fix it. Finally, I can put single area into the label area. So me.lbl area.text equals SNG area. And it should work. Your book has one extra convert. I'm going to ask you to just pay attention to that. We're now into chapter 4 stuff actually. we should take that single area and convert it back to a string. You know, it works this way. I don't get too excited about it. If we are working with dollar signs, I want you to convert it to currency so it looks nice. But for just plain numbers, I really don't mind. So let's run it and see what happens. 5, 10, calculate. Good. We get our same answer. Let's try something with decimal places. 2.2 times 1.1. Oh, who knows what that is? 2.42. Great. So it would look like our program is nearly done, wouldn't it? Not quite. Come back again.